So Anna, why don't you bring up your presentation and I will introduce Anna Hamilton from Tetra Tech. Anna is an aquatic ecologist at Tetra Tech Inc. And she's with the Center for Ecological Sciences, where she's been working with EPA ORD. We've been working together for years, and it's been amazing, to develop methods and tools supporting vulnerability and resilience assessment, adaptation planning, and decision-making. She studies climate change effects on aquatic ecosystems, including biological responses to and indicators of climate change and assessment of implications to water resource management. Over to you, Anna.
Can you hear me?
Yes.
Good, because I wasn't sure I had unmuted. Good morning, everybody. I've been working with Jen Stamp at Tetra Tech and, of course, Jordan West at EPA and Leanne Hoff at the Partnership of the Delaware Estuary to do a case study in Delaware Bay of a framework we developed for evaluating relative vulnerabilities of wetlands. The overall goal of the work is to support practitioners to integrate information from climate change vulnerability assessments into decision-making. We approached this by carrying out a climate change vulnerability assessment in Lower Delaware Bay, obviously with PDE, to characterize vulnerabilities of different marsh stones to sea level rise and storm surge, with additional consideration of marsh condition as a modifier, but also to demonstrate the framework for using data that's widely available for coastal wetlands in the US and are also reasonably straightforward to interpret. This is a diagram of the vulnerability framework. We developed this first for use in freshwater wetlands in Pennsylvania. The 5 steps represent a structured process, right? Starting with classification where you're working and the attributes that represent what your management targets are. And then principal factors, which are the processes that are most important in driving those attributes, metrics to measure those factors, and finally assembling it into a relative vulnerability profile. The system recommends starting the whole process with an identification of your objectives by understanding both your ecological and your decision context right up front. The framework looks at the components of vulnerability separately. So it looks at exposure and then response, in this case, considering response as a practical amalgamation of both sensitivity and adaptive capacity. By looking at your context from the beginning, it allows you to move through and pick metrics that are really clearly linked to your management objectives. Despite this structure, the framework really is flexible in terms of the kinds of data you can use as inputs, as well as the spatial and temporal scales at which you can work. This is our study area, the Lower Delaware Bay. We looked at 6 sites, 3 in Delaware and 3 in New Jersey, where the boundaries of these sites really represent areas where PDE and their partners already had study and management interests. You can see this case study was bay-wide. It really supported across-site comparisons, which might be relevant to, for example, site selection, decision-making. But in fact, it also supported substantial within-site comparisons. So the framework recommends that for real-world management applications, you structure a vulnerability assessment that includes as many of the factors that are important in driving the dynamics in your marsh type, so that what you come out with at the end is assessment results that really show a complete representation of your problems and support the best possible development of adaptation responses to those. So as I mentioned, based on this process, we examined 2 exposures, sea level rise and storm surge, looking at marsh acreage as a response and marsh condition as an additional modifier. This is our framework populated with the way we structured our assessment. So we were in the Delaware Bay in salt marshes. We defined, that's step one of classification. We defined that based on salinity. They run from like 14 to 26 parts per thousand. But we also wanted to set the management context by conceptualizing 3 different management scenarios. One was the potential to manage high marsh areas for salt marsh sparrow. Another was the potential to manage low marsh for provision of habitat for nursery and foraging for fish and crabs. And the third was to manage total marsh for flood and storm surge protection. So in that context, with of classification and management, we set our attribute as salt marsh acreage. That was the response we were looking for, but specifically in high, low, and total marsh. And then as I mentioned, the factors we looked at already were the ones that we thought were most important, driving those acreage changes. And the metrics that we picked are listed here. We used the SLAM model, sea level affecting marshes model, to translate our projections, the scenario of sea level rise that we were looking at, which was a moderate one, into responses in marsh acreage. We projected those out to 2050. We used the slush model to look at inundation as one of the metrics we examined for storm surge impacts. We also looked at number of storm strikes, and we used mid-trend condition metrics to look at marsh condition. We amalgamated these into a visualization of relative vulnerability in step 5 under a series of assumptions that seemed reasonably logical, including greater acreage losses to sea level rise would represent greater vulnerability. Higher predicted inundation depths represented greater vulnerability, but higher rated condition metrics, so marshes in better condition, would be less vulnerable. I just want to very, very briefly introduce that we did more extensive SLAM modeling with very, very interesting results than what I'm presenting here today, which are available in this EPA report that we produced, and I think is going to be made available on the website. So to show just an example using high marsh results, here are 6 sites as they exist at time 0 in terms of land use, and then as they exist with their high marsh shown in orange. Then using SLAM to project marsh acreage response, you can see in the year 2050 areas of wetland gain shown in yellow, and wetland loss shown in black. And now you can compare these across sites, both quantitatively, which sites seem to have the most gains or the most losses, also in relation to the remaining, how much high marsh we started with and how much remains. And in addition, you can use this kind of presentation to look at where the gains and losses are occurring and evaluate that within a site as well as between sites. And furthermore, you get a picture of the distribution of gains and losses and related vulnerability concepts from this result in 2050, which is a management relevant timeline. But you can also think about additional future losses, which in this projection out to 2100 can potentially change your picture of relative vulnerabilities and affect your management thinking, perhaps. Here's the same information, but tabulated both in absolute acres, but also in percentages. And what we did was take the range of percentage gains or losses and bin them into equal size bins, and then color coded them according to gains or losses, with losses in tan to brown and gains in green. And the darker the shading, the greater the magnitude of the gain or loss. One thing that strikes you right away is how different the vulnerability just to the exposure of sea level rise is between high marsh, low marsh, and total marsh. That really brought to us the idea that the way the framework suggests you look very carefully at your management targets at the beginning of structuring a vulnerability assessment is a really important thing to do. Then, as I mentioned, we looked at storm surge both in terms of inundation depth and number of hurricane strikes. Here are some example results of inundation depths, which were projected using the slosh model, for just two sites, Broadkill at the top and Dennis at the bottom. Category 1 hurricanes on the left, category 3 hurricane response on the right, and existing marsh conditions, just for reference, in the middle. And once again, the really useful part of this kind of presentation was the ability to not only compare depth of inundation between sites, but also where it occurred within sites. And you'll see later that we also tabulated these kind of results. And then hurricane strikes. So some of the previous metrics gave down to fairly detailed spatial data. Hurricane strikes did not allow us to look at any differences between hurricane strikes within a site, but we could certainly expect differences between sites based on where they're located along the coast. So how close the sites are to each other, how close they are to the coast compared to being further upstream, and also what the shoreline exposure is relative to the direction of typical storm travel. So for instance, we might expect differences between the New Jersey and Delaware sides of the coast. And in fact, we saw both of those kinds of differences in number of strikes, even though the numbers were relatively small. And finally, we come to marsh condition, where once again, we used condition results from mid-tram. Those are already somewhat categorical. We took the responses and binned them as well and color-coded them. So the darkest green are the best condition results, and the yellow and orange are lesser condition. It allowed us to look at between site comparisons based on overall condition, which is in the right-hand column, and see some interesting patterns, even though once again, averaged across the 6 metrics that we selected as being most relevant to the attribute we selected. The average is the span of values is not very great, but it also showed some very interesting patterns for the individual metrics, which we also found to be relatively useful for interpretation. And finally, we integrated this into a visual representation where the color coding is similar in terms of tone and degree of vulnerability for that metric. And it let us look across all 4 factors that we are contributing to our vulnerability assessment, in this case, across by sites, and then compare within sites and between sites. And in fact, we did discuss and have the ability to generate a singular amalgamated vulnerability number by scaling these to similar ranges. But we found this kind of presentation to be very supportive of interpreting the greatest contributions to vulnerability when we want to move along to how we apply this to developing adaptations. So clearly we were able to see that there were sometimes very big differences between high, low, and total marsh. These different marsh areas support different kinds of ecosystem services. And so it's clear that the concept of vulnerability and the types of results you get really depend on what you set out as your management target. So having these targets in mind when you first structure your vulnerability assessment is really very important. You can also see that if you have differing management objectives, or you might be managing for multiple targets or services, you might eventually run into conflicts and have to consider trade-offs among management interventions. So now the question that we want to think about is how can these relative vulnerability assessment results to be applied to help inform management decisions? And for that, we are going to go to Jordan West.